So what is the actual meaning of diffusion, right? So suppose if I'm in a room and I open a bottle of perfume in one corner, so there will be a lot of particle of perfume here, and I'm interested in how these particles will reach out to the other part of the room. So how they will go in this direction, this direction, this direction. So eventually, suppose if there is another person standing here, then how long it will take for this particles to reach in this part, right? So if you look at the general diffusion equation, then that is equal to dc by dt is equal to diffusion of delta c, right? So, or I should say dc. So what it's saying is that the change in the concentration will depend on what is the difference in the concentration multiplied by diffusion rate, right? However, if you, so this is the equation which is very handy, right? But if you really want to understand the concept in actual terms, and you have to look at the individual molecule. So now if I'm looking at the individual molecule, and this molecule doesn't know that it has to go in this part because there is no other molecule here. So why this molecule will go into this part? Because there is a diffusion equation, that's why? No. So why it is moving? So the movement is actually random. So this particle has no tendency to go into this part. This particle is going to move randomly. So what will happen is that this particle will move in random direction like this, right? So if I have another particle that will also move in random direction like this, and if I look at the distribution of particle, what I'll see is that after time is equal to p1, there is a distribution of particles like this in this area, and nothing will be reached by here. And slowly, when time is equal to t2, then the distribution will look more like this, right? But nothing has reached here still. And eventually, when time will be equal to infinity, then the distribution will look like a straight line, and everything will be homogeneously distributed in the whole room, right? So this is how the diffusion can be explained. Or but to make it simpler, we have come up with the this diffusion equation, where it's basically the same thing, that if you don't have any particle here, then this particle have to reach here, and that reach will depend upon how fast the particle can move and how many particles are here on the first place. Because if there are more particles, so now suppose if I have a less number of particles, so this is how the random distribution will look like. But if you have more particles, then this is how it will look like. And you can see that the tendency of particle to reach at this point will be much faster. So it's easier for particle to reach because this concentration is more. So the same thing, now the diffusion coefficient. So that diffusion will depend on the entropy of the system, right? So how fast the particle can move. So suppose if I'm talking about a single molecule, so we know that the energy possessed by this single molecule can be calculated as kT, where K is the Boltzmann constant and T is the temperature, right? So this is the energy by a particle. Because this particle is very small, this will go into the kinetic energy, and we can calculate the velocity as 2 kT divided by m square root. So this is the velocity of this particle which is moving in random direction. So if you increase the temperature of the system, it is more likely that this molecule can reach faster to the other place. So that's why the diffusion increases when temperature also increases.